Okay, so now we're looking at phosphate use efficiency, which is a major problem here at Lamport, because historically we've used traditional forms of phosphate fertiliser, the likes of TSP for example, and what we've found is this goes into the soil and gets locked up very, very quickly and turns into a solid, so it's not available to the crop. What we're essentially doing is mining this sort of stuff in the likes of Africa, the likes of Tunisia, Morocco. We ship it halfway around the world, turn it into this expensive fertiliser, and then we spread it on fields like this, and if we've got a high calcareous soil like we've got at Lamport, within weeks it's turned back to rock again. So in other words, what we've done is move rock halfway around the world and not actually utilised it. What we're now trying to do is look at ways of waking up that rock, because it's in our soils, we've paid for it, but it's not available. Can we actually bring that back to life? And that's what some of the new products we're looking at are able to do. In this particular case, we're looking at Phosphate. So what I've got here is an example of a calcium solution. And if I add some dicalcium phosphate to this product, some DAP, what actually will happen, hopefully we can see this, it will precipitate out almost instantaneously. And that's exactly what's happening in our soils. It comes solid very, very quickly, not available to our crops. So we've spent years and years actually building up this reservoir of phosphate in our soils. What we now have is the technology to bring this back to life. In this particular case, I've got some Phosphate. If I put this in here, you will see within a couple of seconds that has gone back into 100% solution and back available to our crops. Exactly what we can do in the soil here at Lamport by applying Phosphate, using fertiliser we've already bought and paid for, but it's currently not available.